Financial Modeling, Topic 16, Options and Volatility, Section 7, Compute and Understand GARCH Volatility Model. In the last section, we talked about EWMA, Exponentially Weighted Moving Average Volatility. And we said we liked it because it uses all the data, no need to trim it. It matches the empirical observation of volatility clustering. It also is widely used to forecast short-term volatility, say for days or weeks. The disadvantage of EWMA model, it doesn't incorporate the empirical finding of long-term mean reversion of volatility. The GARCH model is basically the EWMA model plus a mean reversion factor. And what it will do, it'll roughly take your EWMA estimate, and if you're forecasting for a longer horizon, push that volatility closer to the long-term average. So one way to think about that graphically, here are 20-day moving average volatilities graphed, and you can see as high as 60, as low as 10%. It's been running about 14%. Our EWMA model said volatility is going to be 22%. However, the problem with EWMA is there's no time horizon associated with that, meaning that that is a single number that would be used for, say, 1 day or 1,000 days. What the GARCH estimate is going to do, it'll roughly say start at that EWMA value, and if you're forecasting a short-term volatility using GARCH, say for 1 or 2 days later, it will keep that GARCH value, that EWMA value. However, if you're forecasting for, say, 100 days out or 1,000 days out, what it's going to do, it's going to force that volatility up towards the long-term average, which you determine, and that is the GARCH model. So it's the EWMA plus long-term reversion. In other words, it incorporates unequal weights and autocorrelation of volatility, meaning weighting the more recent days more heavily, and also incorporates long-term mean reversion. Now the formula for GARCH looks a little complicated. My forecast for variance at time t, say day t, is some factor gamma, a coefficient, times the long-term average, plus some coefficient alpha times what happened yesterday's squared return, plus some coefficient beta times my forecast from the prior day. So yet alpha, gamma, and beta are my three coefficients. The sum of those weights are equal to 100%. The R squared is that lagged return squared, in other words, squared deviation from a mean of 0. And again, this sigma t minus 1 is basically this formula from the prior day's estimation. So this formula will be used to estimate my volatility for today. Then when I forecast for tomorrow, say period t plus 1, I'm going to use my long-term average plus alpha plus beta to the I, say 1 day later, times the difference between my forecast I just estimated here and the long-term average. So what this formula does here, it forces the the GARCH volatility to approach the long-term average. And let's go ahead and take a look at our spreadsheet. So in our spreadsheet, I had my 2 years of continuously compounded Google returns. I then took the squared deviation from the mean of 0, in other words, the squared return. And then what I'm going to do here, I calculated my EWMA volatility here. If I used a lambda of, say, 0.94, I would take 1 minus lambda times lambda to the I minus 1 divided by the sum of all those 1 minus lambda factors. And I would take my squared deviation, my squared return, times that weight over that sum. I sum all those values up there, and that's the squared deviation from the mean using those weights. I then annualize that and turn it into a standard deviation. So my EWMA volatility is 22.72. I want to now estimate the GARCH volatility, and I want to use a beta of 0.94, which is my lambda in EWMA, and I'll set my alpha equal to 1 minus that, and let's do long-term volatility of 0. So I'm going to set my beta to 94%, alpha to 6%, and my gamma, the weight applied to long-term volatility, to be equal to 0. When I do that and I plug in my GARCH first stage formula here, alpha plus what happened yesterday, that D14 is simply the squared return on my most recent day. So alpha times what happened yesterday plus beta times the day before, which is basically the number right below here. I'm just going to copy this formula down. You can see I just copied it down. And so it's alpha times what happened yesterday, plus beta times the prior day's forecast, plus gamma times long-term average. I'm assuming 0. When I do that and copy this formula down, notice when I go and copy that formula all the way to the bottom, I have to do something special with the last observation, because if I copy this formula down one more spot, it would be referencing a cell that's blank. So again, I can't do this by copying this formula down, because it then references this blank cell. What I have there is that last day. I simply have a reference to the most recent, or the oldest day's square deviation from the mean of 0. So notice I had to change that formula there. I'll go back up to the top. Notice I get my GARCH estimate of 0.025. That is my kind of forecast for that the current day's volatility variance. I then take the square root of that number and multiply times the square root of 252. And notice how GARCH gives me the same value as EWMA, because GARCH is the EWMA model when the weight applied to long-term variance is 0. Your beta is equal to lambda, and simply your alpha is the 1 minus lambda. So actually, this is a kind of another way of writing the EWMA model. However, when I want to use GARCH and I have a non-zero weight for gamma, and what I'm going to do is I'm going to actually get a few of those weights by going to a Bloomberg screen. So let me show you a Bloomberg screen. So this is Bloomberg screen, GRCH. I then put in Google stocks and put the same dates of my data I have for Google stock returns. And then Bloomberg will run a little estimation process to give me optimal alpha and betas. And that alpha is 0.0589, that beta is 0.9361. And actually, they've got a slightly different long-term variance than I did. They got 0.034 instead of the 0.033 that I have. So I'm going to plug in those values. 589 for alpha, 9361 for beta, and then I'll say that gamma is 1 minus those two numbers since they have to sum to 1. So let me put those in. 93.61. Whoops. And my 5.89. And then I'll set set my gamma to 1 minus beta minus alpha. And now I have my GARCH estimate for volatility for that first day, which is now 2288, not 2272. Notice my long-term variance is about 29, or 0.033 daily variance. I'll then use that second formula to then forecast what volatility will be tomorrow. So notice I have my forecast for today. I already have an observation for today. So my forecast for the volatility today is the GARCH estimate for today. However, if I'm estimating volatility for tomorrow, I'm going to take my formula of long-term average plus alpha plus beta to the I times the difference between the prior day's forecast, this number in the cell right here, minus the long-term average. And notice what this number is doing. It's getting closer and closer to that long-term average of 0.033, and then it stays there. And then if I want to estimate volatility for 13 days, because I want to price a 13-day option, I'll simply average my 13 days variances, 13 days of square deviations from the mean. See, I just have an average there. I then take that to the square root to turn it into a standard deviation and multiply times the square root of 252. That'll give me my volatility estimate for an annualized standard deviation for the next 13 days. And if I wanted to price a 100-day option, I would just simply average 100 of those observations from period. Actually, I'm going to start at period 1 through 100. This one's going to start from period 1 through 13, and then I'll do from period 1 to 200. And when I do that, I get estimates of standard deviations over the next 13 days, 100 days, and 200 days. So now I can price a 13-day option, a 100-day option, and a 200-day option. And I have a model which will then forecast a volatility over those different periods. So that is the GARCH model. It is simply EWMA plus long-term mean reversion, where you need values for alpha, beta, and gamma, which give you the weightings of the long-term variance, what happened yesterday, and the prior day's forecast. So that is GARCH.